Okay, use slope-intercept form to graph. Slope-intercept form of an equation is the y equals mx plus b equation. And it's called slope-intercept because the equation, when it's set up this way, when y is by itself on one side of the equal sign, then we can see the slope right here. The number sitting next to x is the slope, and the y-intercept, where the line is going to touch the y-axis, the y-intercept is right here on the end of the problem, this right here. So we can identify our first point on the graph by making a set where x is going to be 0 every time for the y-intercept. But then whatever number is here would be in this spot here. This comes down into the y value. If there's a 7, then this would be 7. If it's -8, then this is -8, that kind of thing. And then you would use your slope to change the y value and change the x value. The top number tells you how to change the y value, and the bottom number tells you how to change the x value of this set that we created first. So if the top number said 4 and the bottom number said 3, then I would add 4 to the y and I would add 3 to the x. You gotta be careful because this is kind of upside down, because your coordinates here, the 0, this is the x and then this is the y. But on slope, the top number changes the y value and the bottom number changes the x value. So you got to kind of take it slow when we're doing this. So let's look at this equation. It says use this to graph in slope-intercept form. Now this equation doesn't say y equals. We need to get it into this y equals mx plus b form. And to do that, we get y alone. So we'll take our 3x plus 4y equals 12, and we'll work on getting the y by itself. So the first thing I'm going to do is I'm going to get rid of the 3x. It's a positive 3x, so I'm going to subtract 3x from both sides of the equal sign, because what you do to one side, you got to do to the other. So we have this right now. And then to get y completely alone, it's being multiplied by 4, so we're going to divide by 4 to cause that to go away. And what you do to one side, you got to do to the other. So now this becomes y equals a -3/4 x plus 3, because that's 12 divided by 4 there. Okay, so now it's in slope-intercept form. We see our slope is always the number next to the x, so it's a -3/4. Notice back up here, with the equation we started with, we couldn't see the slope. You had to get the y alone to be able to see it. So the slope comes down here, and then the y-intercept is at 3 on the y-axis, so the set of coordinates that is always x0, and then that 3 comes down in the y value. All right, so that's our first point that we're going to put on the graph. Our first set of x and y is the 0, 3, and we'll do that in a moment. But to draw a line, you got to have at least 2 points. So we need another set of coordinates, and how we're going to get that is we're going to use this slope. See, it's saying subtract 3, and it's a +4, so add 4. Subtract 3 from the y and add 4 to the x. So -3 and 4 is not a location on the graph. This is not a set of coordinates. If it was coordinates, it would have to be written in parentheses like this. Slope is never a point on the graph. Slope is how you get from one point to the next point. It's directions. So if we're at 0, 3 and we want to get to the next point that works for this equation, we have to use the slope to get there. So this is on the y value, it's saying subtract 3. The x value, add 4, because that's a +4. So the next set then, 0 plus 4 is 4. 3 minus 3 is 0. So 0, 3 was the first set. That came from the equation. And then 4 and 0 came from using the slope to change those numbers. So now we'll come over here. We need 0, 3, and 4, 0. So 0 on the x, 3 on the y is right here. And then 4, 0, 4 on the x and 0 on the y is right here. And so this is the line that's created by that equation. Now the cool thing about the slope is we could actually make more sets from that. We could make 2 or 3 more sets. I mean, we could make an infinite number of sets, but if we just use this over and over and over again. So if we said, okay, do that again. Subtract 3 from the y, add 4 to the x. And each time we'll create a set that works on our line. Let's look. 8 and negative 3 is what I got when I subtracted 3 from this y and added 4 to this x. 8 and negative 3. Let's look at it. So if we go over here and we go to 8 and we go down to the negative 3, sure enough, it lands right here on our line. Okay, so slope, that negative 3 over 4, it's saying to get from any point to any other point on the line, you go down 3 over 4, down 3 over 4, down 3 over 4. You can find some more. Down 3 over 4, down 3 over 4. And you could switch these around and put the negative on the bottom. You could say up 3, back 4. Watch this. So if you go from here, if you go up 3, back 4, you land here. And then if you go up 3, back 4, you land here again. So the slope is helping us find dots that line up with the original that we started with, the y-intercept. So let's do another one of these. Again, we want to make sure that y is by itself. So we're going to subtract 2x from both sides to begin with so that we can get working towards y being alone. Then we're going to divide everything by negative 3 to get y alone. So now we have y equals a negative divided by a negative is a positive. So this becomes positive 2/3 x, and then positive divided by a negative is a negative. So now this is the equation that we have. Our slope is 2/3. Our first coordinates to put on the graph is at 0 and negative 2. Now, again, we're going to use the slope to make the next set. The slope is going to change the y and is going to change the x. So how is it going to change it? Well, it's a positive 2, so it's going to add 2 to the y value. So our y value is negative 2. If I say negative 2 plus 2, that makes this 0. If I say 0 plus 3 on the x, that's the next point. And I could make a couple more points doing that same thing again over and over again. Just add 2 to the y, so 0 plus 2. And I could do it again, 0 plus, or 2 plus 2. So I could keep changing my y values, just add 2 each time. And then on my x's, I'm going to add 3 each time. 6, 9, 12. So all of these will line up in a straight line by doing that. So I could pick any of these to graph with. And so I'm going to go 0, negative 2, and 3 and 0. So 0, negative 2, and 3 and 0. So right here is the line that I would draw from that equation. So let's go back here and look at these others. Would 6 and 2 match this line? Well, if you come out here to 5 and then 6 and then up 2, sure enough, right there it is. And 9 and 4, which my graph isn't that big, but it would get out here, it would be clear up here, yeah, like that. So that works. So let's do another one. Actually, let's do 2 more. Okay, so this one, the equation is already in slope-intercept form because the y is by itself. So we can see that our slope is negative 4, and our first set of coordinates is at 0 and 4. And then we need to create the next set. Well, here our slope is -4, and we need to see it as a fraction so we can see how to change the y and how to change the x. So we got to put it in fraction form. So now it's in fraction form. And so now we can see that we're going to subtract 4 from the y value. My y is a 4, so if I subtract 4, that makes it 0. And then add 1 to my x value. 0 plus 1 is 1. And again, we can keep doing that. We can subtract 4 again from the y and subtract 4 again from the y. We could make as many as we want to that way. Add 1 to the x. So 1 plus 1 is 2. Add another 1 to the x. That makes that 3. All of these work for this line. So if we come over here and graph it, we go 0 and 4 on the y value. And then we have 1 and 0. This graph is by 2, so be careful when you graph, when you're graphing things, to make sure you see whether the graph is marking them like every 1 or every 2 or every 5. You got to be careful about that. I always mess it up. Okay, then 2 and -4 comes down to here. And 3 and -8 comes down to here. See how they're all lining up in a straight line here? So you only have to graph 2 points. But, if you visualize the others, they should all line up. And if they don't, you've done something wrong somewhere, because they will always line up. This one also is in slope-intercept form because the y is by itself. Notice how it doesn't have the y-intercept sitting out here. Well, nothing, like if you have no money in your pocket, you have 0 money, right? So you could say, oh, that's the same as saying plus 0. So we still can see the intercept, the y-intercept is at 0, 0. And then the slope being -8, we'll call it -8/1. So that's telling us to subtract 8 from the y and add 1 to the x. So there we have it. And again, if maybe your graph isn't big enough, you could change this. You could call it 8/-1. So we could have said, okay, instead add 8 to the y and subtract 1 from the 0. So all of these will line up. So if we come over here, we have 0, 0, which is at the center. We have 1 and -8 down here. And we have -1 and +8 up here. And there you see how they're lined up. It's hard to draw a straight line freehand, but there we go. That's how we do it.